Hello, everyone. In this video, we'll present a case study on data compression using Hofmann coding. Compression data is a common task. There are many utilities available for compressing files. This section introduces Hofmann coding, invented by David Huffman in 1952. In ASCII, every character is encoded in 8 bits. Hofmann coding compresses data by using fewer bits to encode more frequently occurring characters. The codes for characters are constructed based on the occurrence of characters in the text using a binary tree called the Hofmann coding tree. For example, this text, Mississippi, this is the corresponding Hofmann coding tree. M is coded using 3 bits. I is frequently used, so it gets a short bit 1, and S is coded as 0, 1, and P is 0, 0, 1. If you look at the P is 0, 0, 1 from this coding tree. The text Mississippi is coded as this using 21 bits. You can use this coding tree to decode the binary string, starting from this 0, 0, 0, that is M. Then 1 is I, 0, 1 is S. This is how you translate the sequence of binary bits into the text. To construct a Hofmann coding tree, we use a greedy algorithm as follows. Begin with a forest of trees. Each tree contains a node for a character. The weight of the node is the frequency of the character in the text. Repeat this step until there's only one tree. We're going to choose 2 trees with the smallest weight and create a new node as their parent. The weight of the new tree is the sum of the weight of the subtrees. This step reduces the number of trees by 1. Eventually, all these trees are merged into just one big tree. Here's an example. We have this text Mississippi, and the frequency for M is 1, for S is 4, for I is 4, and for P is 2. So these are 4 trees, isolated trees to begin with. And the next we're going to pick the smallest weight is 1, 2. So these are less frequently used. 1, 2. Combine this together and to form a new tree. And this is the total weight is 3, there's the root right here. And now we're going to have 3, 4, or this 3, 4 for this I. And let's pick S here. We have this is 3, this is 4, combined together is 7. So now we have one less trace. And finally, you only have this 2. Combine this 2 together. This is the weight, it's 11. So this is all together. Now you're going to assign this binary numbers for 2 branches, 0, 1, 0, 1, 0, 1. So this is how you construct a Hofmann coding tree. Let's look at the implementation. This is the implementation. Let's start with this is the main method. We're going to prompt the user to enter a text. Invokes get character frequency and to get the frequency of the text. So now this has this, let's look at all the characters. So we're going to look at this get character frequency. So here is get character frequency. So this are all the ASCII characters, 256. So we're going to get all of this. And so look at every character. So we get every character and cast it to int and counts this corresponding occurrence. So all of this, after this is done, we get the occurrence. So now we get the occurrence now. We're going to display and the ASCII code, character, frequency, and code. So first, now let's do this construction of the Hofmann tree. So this is get Hofmann tree. And using this counts the frequency. And this is get Hofmann tree. So we're going to create a heap of all this trees. So each element in the heap is a tree. This is a tree. So this is the right here is the tree, right? Get Hofmann tree, here is the tree. All right, so let's look at the tree here. This is the inner class for tree implements comparable tree. So we're going to have this comparing these 2 trees now. This is a tree. How you create a tree? So you can create a tree in multiple ways. So this is 2 ways. One is here. It's a single character. So you have the weight and have the element. And now you can create a tree using 2 subtrees. So this is 2 trees. And so you have put them on the left and the right. And this is new node. And the new node has the weight, is the weight of the 2 trees together. This is the single node, weight and element for this node. All right, so now you can see this is the class node. So here's the element, and this is the weight, and left and right. So now, and the code is not assigned at this moment. So this is just give it empty. So this is node. And this is the constructor. You can construct a node using weight and element or using this NOAH constructor. All right, back to this now, the algorithm get Hofmann tree. So we have this a heap, and we are going to add all this single element tree node for each character. So you create a new tree, and this is the weight, and this is the character, and into this heap. So this is initially you have all these trees in the forest, so they're in the heap. So now let's look at this heap.getSize. If it's greater than 1, and we are going to pick the first two from the heap and combine these two together and put it into the heap. And now you are doing this repeatedly, and every time you execute this body of the while loop, you reduce the size of the heap by 1 eventually, and you have this is the everything is removed, and this is only there's going to be only 1 in the heap eventually. So now you're going to remove this, the last one. It is the 1 that is the tree. That's the tree, the final 1 tree for everything. So this is get Hofmann tree. Back here, you have this tree. So now you get the root of the tree, and here is we're going to assign all the code and for every node in the tree. And this is here is so we're going to look at this const if not equal to 0. If 0, it is the text is not in the this character is not in the text, so we're going to ignore it. So if it's not a 0, we are going to display, and the ASCII code and the character and the frequency and the code. So this one here is the get code here, and get code is right here. We're going to do this recursively. Assign this here is the new string. This is the 256 characters here, and we're going to assign this code. So here's how you're going to assign, and 0 and 1 to the left and right, and for this, and doing this, it is, and you do it recursively, invoke the assign for every subtree. That's the entire program for constructing a Hofmann tree. And so you have a text as input, and now you can find the Hofmann tree. Thank you for watching this video. See you on the next video.